if you're here for the main show, which is, of course, um, um, what is the main show? Kelli Wakefield talking about the volcanoes of Arizona, and she will do that in just a moment. I just want to let you know that 3D exhibit is available online. It's still under construction, but it is available under the exhibits tab on from the main page at PinalGeologyMuseum.org. You can get there through the online exhibits through there, and for the 3D exhibits, and it's still under construction, but there's a lot of stuff there already. More will be coming shortly. But if you are interested in seeing the museum online exhibit, we are also open on Saturdays, 10 to 2. So I hope you will come visit. Ray's doing the Saturday openings right now, and he will continue to do that. So what I'm going to do now, let's see, what am I going to do? I'm going to come up with Kelli here, and she is going to be able to say hello if she wants. We worked out previously that, and so she doesn't have to go over this. We worked out previously that her invited students can check in the comments. A couple of them have already done that. And so she can do that, and she can see that you have attended, so she knows who you are and all that. And Carlton asks a question already. I've put, as you can see on the screen, if you have questions during the talk, put them in the comments, and we will do that. And hopefully, at some point during your talk tonight, Kelli, you can answer whether Sunset Crater is still alive. And because Carlton wants to know that. Other than that, I'm going to let Kelli talk about anything she wants to talk about.
Oh, that's a little dangerous.
Well, hopefully you. Other than that question, I can edit it out. This is only live to 25 people or so.
My students know me far too well, so they are probably prepared for whatever comes out of my mouth.
I'm open. Miranda Ray says anything she wants, so
it's a dangerous thing.
It is. Kelli is from Mesa Community College, geologist there and teacher, as you may have guessed by talking about her students, and been around for a little while. She's a new name to me, but I've only been in Arizona 2 years. How about that? So do you want to talk about yourself? Do you want to go solo for a moment here on the screen?
Oh my goodness.
Are you ready to start?
Yeah, I can do a little. I'm Kelli, like you said. I have been teaching at Mesa for a while, and I love it. And that's where a lot of people know me. You may have met me at the Flag Gem and Mineral Show that is there on campus. I like me some volcanoes. So the last time we held it, I was the one with the trash can volcano that I was blowing up all the time. My background is in planetary geology. I do, at least back in grad school, I did a little fluvial geomorphology, but now since I'm teaching, I have kind of fallen in love with natural hazards and geologic hazards, which I know sounds kind of bizarre. But I teach a class at Mesa called geologic disasters. And so we spend a lot of time talking about volcanoes and earthquakes and tsunamis and stuff. So this was when Ray invited me to talk, and he was like, you can talk about whatever you want. I was like, let me talk about volcanoes. And so, of course, he let me. And so, yeah, I'm working on convincing Ray that he needs to go with the pink hair too, though.
I'll
Okay.
second that.
I know, right? He would look lovely. We could even go, teal if you like. That seems like that'd be a good color for Ray, right?
Sure.
But he's been wonderful, and he hosted our geology club at his museum just a couple of weeks ago, and we had a blast getting to look around the museum and digging through the kids' dig pile. Although I had to make sure everybody only took like a couple of rocks out of there. All right, Bob, when do you want me to start my whole thing? Do you want me to just jump right in?
Sure. I just put your slides up on the screen so you're ready to go.
Awesome. Okay. So welcome, and we're going to talk about volcanoes today, and we're going to look at a lot of volcanoes in Arizona. But like I said, I teach a course for people who aren't really geologists, and I'm not sure sort of what everybody in the audience's background is. So I'm going to spend a little bit of time talking about what volcanoes are, sort of to get us started. But Arizona is full of really awesome volcanic features from all sorts of different ages. This is a pretty well-known image of that shows a map of some of the volcanoes throughout Arizona, and I love it because it's all marked by age. But you can see some of the most recent ones are going to be the red volcanoes, and those are going to be some of the very youngest volcanoes in all of Arizona, even as young as just a little under 1,000 years old. So we live in a very volcanically active area, and it always surprises me when people just have no idea. And that's one of the great things about my job is I get to make sure people know these sorts of things. So we're going to look at some examples from some of these younger volcanic fields as we go. All right, so what is a volcano in the first place? And, we all have kind of a picture in our head of it. And I've got you some moving stuff because I really love pictures and all. So you've probably all been watching the news and seeing the La Palma volcano erupting in the Canary Islands. So this is a part of Spain, but it's just off the coast of Africa. And this last erupted back in the 70s. And just recently, just this year, it's woken up and it's putting on a beautiful show. So far, it's done a lot of damage to the surrounding villages and cities. I did see a headline the other day that may have claimed its very first victim. And that is not surprising that there haven't been any yet, just because of the type of volcano it is. So this tends to be the picture we have of it, right? Of big, beautiful lava flows and lava shooting off in the air. So a volcano is just a vent somewhere in the earth, some kind of hole or crack where lava and gas and ash can escape. And most of that is driven just by the gases that are trapped within that. Right? But this isn't the only way we see volcanoes. Some volcanoes look a little bit more like this. So this is Colima volcano. This is in Mexico. And in this case, you can see there's like no lava. And that's one of the things we usually think about, right? Is volcanoes equals lava. But a lot of volcanoes are very ashy, and ash ends up playing a really important part. And also the gas, if I go back, I want you to kind of notice, look down towards the volcano, you can sort of see the ash get pushed down. And that's just because of the gases starting to escape, which is pretty amazing. So this is a different view of what volcanoes can do when they erupt. So let's talk about then what some of these terms mean then. So I mentioned ash. So what is ash? Because we think of ash with fires, right? Fires cause ash, but this is completely different, right? And so volcanoes, it's not smoke, it's a special material that comes out. So this is a picture from a volcano erupting in Chile just about 10 years ago now. And you can see that beautiful ash plume. But if you take that ash and you hold it, it feels soft and kind of like flour. But if we put it under a microscope, you can see that that ash is actually teeny, teeny, tiny shards of glass, basically obsidian, just very small shards of it. So one of the reasons why volcanoes can be so dangerous health-wise is that's pretty scary, just in general. So this is ash. Then what about lava? And we're going to have to stretch out a little bit with some of my background here. So lava is molten material that's coming out of a volcano. It has melted rock, but it also has gases in it, and it has crystals that are growing in it, some from the rock cooling. And in my little GIF here, you can see that it started to cool off and crystallize at the tops. And sometimes it's just crystals that never melted in the first place, that it just drags along with it. So lava is pretty cool, and this is that beautiful image we have of lava. But there's some very special types of lava. All right, so we refer to these as the igneous compositions, and I'm going to show you some examples. So mostly this is based on like silica content, okay? That SiO2, it ends up playing a really important part in what our volcanoes look like, which is pretty cool. So I'll give you some examples here. The komatiite lavas. Now, these don't actually erupt anymore. We know they did in the past. There are komatiite lava flows in some really old rocks. But these melt at an incredibly high temperature. They're very, very hot. And so the earth doesn't really get that hot anymore. So for the most part, we're going to ignore this one, but it's worth throwing in. And I like this table a lot. We also have basalt. Now, if you notice, the komatiite is green. That's because it's mainly olivine. Basalt is going to be usually really, really dark in color, sometimes black, sometimes kind of brown. You'll even get orange in there because it's got a lot of iron. And then iron makes it pretty dense, but it can rust. And so you can see oranges and browns every once in a while. This is a little bit cooler than the komatiite requires, which is good because, you know, the earth is hot enough to create these lavas. So you can see it's pretty dark, and it's going to be really low in silica. Usually the less silica, the darker in color it's going to be. And basalt makes up a lot of the Earth's surface. We can't see quite all of it because it's this is what our ocean floors are made of. Basalt makes up the vast majority of the surface of our inner solar system. So Mercury, Venus, well, I mentioned Earth, the moon, Mars, they're all covered in basalt. So this is a pretty important, but a really common kind of rock. Now, if we go a little bit cooler and also a little bit lighter in color, we end up with andesite, which is interesting. Andesite, this is actually named after the Andes Mountains, which are volcanoes that erupt andesite lavas. And then finally, our rhyolite. Rhyolite has the highest silica content, and it's also the lightest in color, and it's the coolest lava, and relative, right? Everything's all relative. So only 650 degrees here. Some of you who are rock hounds around here or mineral collectors may recognize my my garnets here. I am blanking off the top of my head what the name of this was, but this is it's a really common rhyolite with garnets that are pretty popular for collecting. Okay, so what does this have to do with anything? Well, composition affects what we call the viscosity of the lava that gets erupted. So we define viscosity as resistance to flow, but I'm going to play a little video just so you can have a picture in your head. These are different motor oils, and that's usually when people have heard of viscosity, because you have to choose the viscosity of the oil to put into your car. So you can see the 0W30 weight. It's pretty runny, right? It all came out really, really easily, but the further and further to the right we go, the thicker it gets and the less that it wants to flow. And that's the viscosity. So the left oil has the lowest viscosity. The The one on the right that hasn't dripped at all yet, that's the one that's going to have the highest viscosity. And so each one of our compositions, our igneous compositions, has their own viscosity. And so to kind of, I like food metaphors, and I like to sort of kind of describe things. So a komatiite lava, of course, nobody's ever seen these. They don't happen anymore. But it's probably had a viscosity kind of similar to light motor oil. You can see this is a pretty runny motor oil here. But a basalt, kind of your average basalt lava flow, has a viscosity very similar to ketchup. So if you kind of think about how runny that is, that's going to be our pretty runny lavas. It runs a gamut, but this is kind of your average. For andesite, we're getting a lot more viscous and a lot thicker. And so andesite is, in viscosity, it's pretty similar to like creamy peanut butter. We don't really have, I don't have videos of andesite lava flows. Most of the lava flow videos that I ever show are basalt, just because andesite lava flows can be kind of dangerous. Because it's so thick, it traps a lot of that gas that's in the lava, and that tends to make it a lot more explosive, which is pretty dangerous. So of course, on the far side of things are rhyolite. Now, rhyolite is incredibly thick. It barely just kind of moves out of a volcano as it's being erupted. And so it's got a really, really, really high viscosity. And it's sort of similar to wall putty is what everything kind of compares it to. So you can see this person, this is actually from a website on how to replace your windows. So this is the putty you use around the edges of your windows. And you can see like it's holding the fingerprints there. It doesn't almost look like a fluid anymore. It's almost solid because it just sits there, but it is manipulatable. So it is a fluid, just a really, really viscous one. And that's what the rhyolite looks like. Even rhyolite eruptions can make these really big, long, steep spines, even just because of how thick it is. So what does this matter for us? Well, in general, for one, like I mentioned, it ends up setting how dangerous a volcanic eruption is. So the more viscous it is, the more difficult it has, more difficulty flowing, and it traps a lot of gas. And so the picture on the left there is an eruption of the dome in Mount St. Helens. I think this is the 2008 eruption, although I could be wrong. But on the bottom, we have our low viscosity lavas. And in this case, it's flowing easier, gas is escaping. It doesn't tend to be quite as explosive. And that's why the people, there around La Palma volcano are fairly safe for the most part. And that's why, you can go vacation on the big island of Hawaii when Kilauea is erupting, is because it releases the gas pretty easily, so it doesn't get too explosive. The other thing, and this is going to tie into our volcanoes here, about our Arizona volcanoes. The other thing is it actually helps kind of create the shape and the type of volcanoes. So really runny lavas tend to make volcanoes that are really wide and broad and gentle sloped. And really thick, viscous lavas tend to make volcanoes that have really, really steep sides, and they don't move very much. And some of those, even like it doesn't erupt on the outside, it just kind of fills in from the middle and fills it up kind of like you would a cupcake. And so what we're going to do now is we're going to look at some types of volcanoes and that are created with the different viscosities and the different types of lavas. So I'll talk about the volcano type just a little bit, and I'll show you some Arizona volcanics. There are thousands of volcanoes in Arizona, and that's just the young stuff, not even getting into the older materials. And so this is going to be just like a little hop, skip, and a jump skim over the surface for you. Just to kind of introduce you to some, and many you've probably heard of, some of them maybe not. So hopefully you'll see something kind of cool through here. All right, so we divide our volcanoes into basically like 4 volcano shapes and types. All right, our first type here is what is referred to as a shield volcano. These are the biggest volcanoes on Earth. They erupt for millions of years. The eruption itself can go on for decades. And so these are the ones that don't look anything like you would think a volcano should look like. So the example that's here, just to kind of introduce it, this is one of the Hawaiian volcanoes. Pretty sure this is Mauna Kea. So you can see that kind of wide, broad shape to it. Now, these are going to be made out of basalt because that's the runny stuff. Of course, where does the name come from? The name actually comes from the shape of it. And so I get an excuse to flash Captain America for you today. But Captain America has like his shield, right? His vibranium shield. If you were to take that shield and lay it down on the ground, that would basically be the shape of a shield volcano, like not so tall, but very wide and very gentle slopes. And so that's where the name of that comes from. And so let's look at, this is just an example kind of showing you a little bit of how they form. Mostly just lava flows. We do know some of the, and they come in different sizes. There's fairly small shield volcanoes that are really common in like Iceland, is kind of where they're best known. But here in Arizona, the Sentinel volcanic field has quite a few of these small shield volcanoes. And a lot of that can be because of lava flows. For some of the really big ones like in Hawaii, a lot of that is fed by lava tubes even. So that's where the lava flows end up crusting over and flow underground, and they flow for tens of miles that way, and that's one of the ways it gets so darn big. All right, so a few examples from here in Arizona. This is one that I don't know if I'm that familiar with, which is really a shame. I feel like I need to go visit this now. But this is House Mountain. It's near Sedona, and it's a beautiful shield volcano. And if you look at it from the sky, you can actually still see that kind of shield volcano shape in that inner crater rim, which is amazing. So this one, like I said, it's just outside of Sedona. You can see in my map where this was. So dating some of these isn't super easy. For one, shield volcanoes form over like millions and millions of years. So sometimes if you go and do like argon dating, you can get, you know, a range of dates kind of just based on where those lava flows were. There's some great work that's been done. There's a paper specifically on this little group of volcanoes here, which is really fascinating. But we're looking, this erupted probably somewhere around like 13 to 15 million years ago. So geologically pretty young. But this one's pretty amazing. And you can see there's quite a few other sort of volcanic vents and stuff in the area. And that's what's marked on the map here.
Kelly?
Yes.
A comment from Mike at Arizona Geological Survey that there are some small shield volcanoes in the Mormon volcanic field south of Flagstaff too.
Oh, awesome. I know I recognize the Cinder comes through there, but thank you. Thank you for that. Let's see what else I got. I got a few more in here. The Coyote Hills, this is part of the Springerville volcanic field. And if you look at, you got a nice kind of landscape shot here, and then there's an overhead view of it. So you can see it from either way. Down in the very bottom, kind of southwest corner of the map is actually the town of Springerville. So this kind of looms right over Springerville. And the Coyote Hills are fairly young. Most of the volcanic field is between like 2.9 million and 820,000 years old. So not super old either. I know that always feels bizarre, right? Oh, it's just a couple million years, it's nothing. But this is a really cool volcanic field with really neat features and a lot of different types of volcanoes. So you're going to see a couple of them show up from this particular area. Now, if we head a little bit southwest, we run into Arlington Volcano, and this is part of the Sentinel volcanic field. This is a pretty cool one. If you ever, I make the drive out to like San Diego quite a bit. We've got family in Southern California. And so we drive through this. I've actually got a video on my YouTube page of me like pointing around at the things behind me in this particular field that you can see. But Arlington Volcano itself here is one of those smaller shield volcanoes. And Shelby Cave, I actually went to grad school with her at ASU, and she did a lot of work in this area and figuring out dates of the volcanoes through here. So she has reported the age of the Arlington volcano to be about 1.28 to 3.28 million years. But it probably, I know her work said it probably only erupted for kind of a shorter period of time there. But there's lots of great things throughout this field too. And you can see some of the other volcanoes that are marked on that map. And of course, if you're one of our students from MCC, you have definitely looked at pictures and maps of Joe's Hill. Somehow we always like pull that out. But Joe's Hill is a super cute little shield volcano. If you didn't know it was a volcano, you might miss it completely. But this one is right on the Agua Fria River, like right over the canyon. Right to the east of I-17. If you're ever driving up I-17, this is one of those really cool places to get a look at some really cool Arizona geology stuff. But the Sunset Point rest stop, you like stopping there. That's a nice place to kind of hang out and see the view off to the Bradshaws. But if you look the other way across the interstate, you'll see Joe's Hill. And there's hikes you can do out there too. So I believe it's kind of accessible too. But Joe's Hill is about 10.8 million years ago. And this doesn't fit kind of nicely, particularly nicely into one of those volcanic fields, but there is a lot of lava flows throughout that area. So some cool little shield volcanoes. And these are all basalt. When these were erupting, it would have been a lot like, visiting Hawaii, maybe lava spurting every once in a while. But for the most part, these are fairly calm eruptions. So the shield volcanoes, the biggest ones. Now we're going to look at some of the smallest volcanoes. The cinder cones, these are made out of basalt as well, just like the shield volcanoes. And in fact, you find cinder cones on shield volcanoes sometimes. So the name comes, number one, from their shape. They make a perfect little cone, and some of them are 300 meters tall, but for the most part, they're kind of small. And the cinder in the name is because when this erupts, I think I've got us a little video. When a cinder cone erupts, it mainly like shoots little spurts of lava up in the air. And those little spurts of lava actually cool in the air as they fall. And then they just sort of build up into this little rubble pile. And those little pieces are about the size of a walnut. A lot of times it's scoria, which is like a basalt with lots and lots of little holes in it from the gas escaping. And they're all about walnut sized. And so they're basically little rubble piles. They don't erupt for very long. We say these are monogenic, which means they only ever erupt once for the most part. A lot of cinder cones start erupting and stop erupting within a year. So these can go pretty quickly. Some of the longer lived ones, like Paracutin in Mexico, that one erupted for about 10 years back in the 40s and 50s. And that's when a lot of people are sort of familiar with. But Arizona has so many cinder cones. This is one of the most, like, if you go just like based on numbers, there's more cinder cones than any other type of volcanoes. So some of our famous cinder cones, these first couple are ones everybody sort of knows. Sunset Crater, this is just north of Flagstaff. It's a beautiful color. The name comes from the color, that orange at the top tells us it was probably erupting through maybe some groundwater, and the lava was rusted. Basically, it oxidized, and that's why we have that really pretty green color. It is within Sunset Crater National Monument. Highly suggest going to visit. There's lots of other volcanoes within that area too. But Sunset Crater, its claim to fame is it's Arizona's youngest volcano. So it erupted in 1064. that was like no time ago. It's kind of amazing. I had a list at one point, and I wish I'd pulled that back up, of kind of what was going on worldwide at the time Sunset Crater was erupting. I think one of the things, Pisa in Italy, when they started building the Duomo Cathedral, they started that like about the same time Sunset Crater was erupting.
The Norman invasion of England was that year.
Oh, that sounds right. Thank you. So yeah, so this is like in human history, which is, very, very young. I'm always kind of struck by just how young it is. We do know that people were living around it at the time. The Sinaguans had homes around it. They have found pit houses actually under the lava. There were places in some of the Bonita lava flow, that's the name of the lava flow that comes out kind of to the right in this image. The Bonita lava flow where it actually has imprints of corn, like corn cobs. And why it's there and how it ended up in the corn, because it's kind of obvious. They've got some on display at the National Monument Visitor Center if you go there. But we know the Sinaguans lived there, and it must have been horribly frightening. It probably started out with a fissure eruption, and then everything sort of coalesced and built into this one big cinder cone. And that's a pretty common occurrence. We saw that happening just a few years ago in Hawaii, where they had all the fissure eruptions. And even La Palma, when it started, it was kind of a fissure eruption and then ended up kind of coming into one specific cone. So yeah.
Kelly.
Yes.
I have a couple of questions here that have come in that this refer to this or something previous.
Okay.
So I'm going to interrupt you. Steve mentions a green beach in Hawaii that's less than 5 million years old that has peridot from basalt that looks a lot like your picture of comatite. And is olivine a determinative characteristic of comatite or
Comatite.
comatite? And how do you differentiate between the two?
Yeah. So comatite is an ultramafic rock, and at least that's the comatite is the volcanic version. The picture I showed is actually like we call it an intrusive rock. That's a peridotite, and that's mainly made out of just olivine. And that's actually a piece of the mantle, which is kind of awesome. Let me go back because it's always worth looking at this picture. I love using these in class because they're just beautiful. And how often do you get to hold a piece of the mantle? So you can see this is a big chunk of rock with nice big crystals of olivines. There's a few other things mixed up. But this is actually a piece of the mantle. And this comes from the San Carlos Reservation. Everybody sort of knows this one, from Peridot Mesa. And this would have been kind of I didn't actually include it in my volcano, sadly enough. I thought about kind of putting it in some of the other sort of weird ones, but I was trying to stay with kind of our main types. But that particular volcano was powerful enough as it was erupting, it was actually pulling chunks of the mantle up with it, with the magma as it was ascending and erupting. But the green sand beach in Hawaii is made of olivine, which is the exact same thing. Now, I mentioned earlier that we don't have comatite lavas because the earth just isn't hot enough to melt olivines. But lava comes from the mantle, which is mostly olivine. But when we get those kind of special tectonic locations that can melt the mantle, that start to melt the mantle, the olivine doesn't melt and everything else does. And so sometimes those little crystals of olivine that didn't melt just get pulled up along with it. And so the green sand beach in Hawaii is from a cinder cone eruption that just erupted a lot of those little crystals of olivine. And they're heavy, they're dense because they're full of iron and magnesium. And so the beach is able to kind of, the water and the waves have washed some of the lighter stuff and more the basalty stuff away that left those crystals of the green sand beach behind. I was looking, I know I had a jar of that sitting around here. But yeah, so it's the
Okay.
exact same stuff, and they're both coming from the mantle. It's just a little bit different process to get them up
Right.
there.
He also wonders where in the world komatiite can be found. Do you have any?
Mm.
I have a general answer, but you might have.
Yeah, so chromatites, you have to find those rocks. I think they have to be at least 2.5 billion years old. The locations that I know of, sort of, I can't give you an exact one, but I know there are chromatites in South Africa, and
In
I
in
know there are
Komatiite
chromatites.
Valley,
I'm sorry.
Komatiite Valley.
There, yeah, that's where it comes from. There, and India, both of those have pretty old rocks. The komatiite itself, the volcanic rock, is really cool looking, but like super rare, and it weathers pretty easily at the surface. So there's not just a whole lot of it.
Yeah,
I
there's an
was,
island off Colombia,
oh no.
and it basically Archean age shield areas
Mm-hmm.
is what I have found in.
Awesome. I got lucky down in Tucson. One of the dealers at the Mineral City complex. I bought a komatiite from him, and I was so excited because they're really fascinating and just super super rare.
Okay, going back toward sunset. Thank you.
Mm-hmm.
Miranda Rose wants to know. Let's see. Does the giant landslide near Sunset Point have any correlation with Joe's Hill?
Ooh, that's a wonderful question. Well, Mike, wherever you are from the Geologic Survey, you may know better than me. I think Joe's Hill is older than the big landslide, so I don't know if those are directly related. But yeah, if you don't know, like that Sunset Point rest stop, that huge cliff that you get to look out on, it's a landslide scar. There's this humongous landslide there. It's amazing. And then as you go north, there's a whole bunch more. But yeah, I don't, off the top of my head, I wouldn't say that I think they're related, but I absolutely could be wrong.
Okay, that we have a couple of questions about future threats and current threats. I'm going to save those for a little later in your talk because I bet you're going to talk about them.
Okay. Well, I actually, being here in our Sunset Crater part is a nice time to mention it. Where'd you go? There we go. Because this is the youngest volcano in all of Arizona. Now, this is part of the San Francisco volcanic field, and it goes all the way from is it Bill Williams Mountain? I don't know why I'm blanking. I'm sorry. All the way over like west through Williams, and then sort of all the way towards the northeast to where like Sunset Crater and Strawberry Crater are. And it gets older and older and as you go that way. So there's really good what it looks like evidence that it may be driven and these may be from like a hot spot. And so that means the North American plate is moving over that source from the magma. And so any new volcanoes are going to be in the Sunset Crater area or just to the northeast of that. Sunset Crater itself is probably never going to erupt again. Like I said, for the most part, cinder cones are monogenic, so it's not likely to erupt. But I think it's more of a question of just when the next one's going to erupt rather than if another one will erupt. And I always say in class, I'm like, I sort of hope it's within my lifetime because I would love to go see it erupting here in Arizona. And I don't know how terrible that sounds because it's away from Flagstaff and it's pretty sparsely populated up there. So it would probably be a fairly safe kind of eruption. And it'd be a party in Flagstaff if another one started erupting.
Yeah. When people say it's never going to happen in geological terms, they got to remember we got a 4.5 billion years before the sun blows up. We got a long time to wait.
Right. We have. So geologic history is a very, very long time, and sometimes that's a concept that my students have trouble kind of grasping, because I'm like, oh, it's only like 10 million years old. That's nothing. And sort of geologically speaking, Sunset Crater is like very, very young. And some of those other volcanoes in the San Francisco volcanic field are really young. So it'll happen again. Yay. Any other questions?
Let's see.
Are those the main ones that are?
Yeah. Diana wants to know about current threats now, but that's you'll get to that, I'm sure.
Yeah, I mean, our current threat is something happening up there in Flagstaff, and it's pretty highly monitored. There's our first clue probably that something's going on is going to be some sort of seismic signal. We'll start seeing earthquakes because there's lava's moving through the ground and getting really shallow. It creates a lot of earthquakes, not necessarily like big, Hollywood movie style earthquakes, but definitely ones that'll be recorded and that you can see earthquake swarms in these volcanic areas. And it's all's quiet for right now in this area.
And Mike confirms that the landslides are much younger.
Okay, thank you. Thank you so much, Mike. He's a great guy. Mike is a super cool dude and a great person to ask.
Him. Mike, what are you doing next month about this time?
I'll put a little plug for him. He's great. Okay, let's see. We're going to stay up in the San Francisco volcanic field. Like I said, there are hundreds of cinder cones. There's well over 600 cinder cones in the San Francisco volcanic field. So literally, if you're anywhere around Flagstaff and you're like, hey, that's a nice hill, it's probably a cinder cone. That's just kind of how it works. And you can see where they mine a lot of them for cinder blocks and paving stones, and for road materials. They do a lot of mining of these up there too. One of my favorites is SP Crater. So SP Crater is kind of due north of Flagstaff. If you're playing around on Google Maps or Google Earth, it is so easy to find because of this beautiful, beautiful lava flow. And really, SP Crater is like literally the textbook cinder cone. I don't know how often I've looked in textbooks and looked at the pictures for cinder cones, and SP Crater is there. So it is well known, well recognizable, and part of it is just because it's so pristine. And this amazing, amazing lava flow. So dating this particular eruption has been kind of tough. There's a lot of kind of numbers and a lot of uncertainty. Kind of the best numbers, just based on the chemistry for the most part, looks like it may be like 70 to 72,000 years old. And for it to look this perfect and beautiful, that sort of seems a stretch, and that's one of the reasons why that number has caused some concern. There have been some other work that put it a little bit younger, like closer to 10,000 years, which makes it seem a little bit more to fit just how pristine it looks. But it's pretty cool. If you are into hiking, this is a fun one to hike. It ain't easy because, like I said, cinder cones are basically rubble piles. So like for every step you take up, you'll slide back about 3. So it'll take you, a couple hours to get to the top and like 10 minutes flat to get down. It's a pretty fun trek, kind of skiing down the cinders. But it is pretty popular to hike up. You can also go through the lava flows pretty well. This is a really fascinating one. It's right on the edge of a fault, so you can see some structural control in the area. You can see kind of along the top part of this image here, the lava flow. You can actually see where the lava flow made levees on the side, so the edges kind of cool and hold the lava flow in and help channelize it, but you can see where it overflowed in a few points, which is just beautiful. There's lots of volcanic bombs through here, which are just like, they're these, well, it's kind of a chunk of rock bigger than a bread box that got tossed out of the volcano. But those bombs are often like, they're streamlined because it's a piece of lava that got shut up and kind of cooled as it came down, and you can see streamlines and stuff. They're pretty amazing, and there's quite a few there. And it's pretty easy to access too. It's on land. I think the Babbitts own this land, but they're pretty open to people coming in as long as you don't, you know, you don't get too silly. But you can see there's a little dirt road that goes right on the first of the lava flow. So this is one a lot of people know, a lot of people have hiked. It's pretty amazing. This is when I get to tell you a fun story, that because I know I know some of us love telling the story of the name though, and this is totally worth it because it's related. So the very top of SP crater is it's ringed with this agglutinate. So basically, like, the lava was getting kind of thick and spattered towards the end, and it's kind of formed this sort of protective shell around the top. And it's these big brown kind of splatters. And the word goes that there's a couple of dudes back in the day, and they had hiked to the top of it, and one of them looked around, and of course, you're at the top, there's a circular pit, there's brown splatter all around it. And this guy, I'm going to use a naughty word, so if you need to put your little fingers in your ears, he declared it looked just like a shit pot. And that's what it got named. And the story goes that when they sat down to actually make the map, the cartographer was like, I'm not writing that. So we shortened it to SP, which is why it's SP Mountain now. But this has got a lot of really cool volcanoes around it too. Colton Crater is just to the south. That's another pretty nice volcano to visit. So there's a lot of cool things going on in this area. Highly suggest this one. Staying here, you notice I'm staying up in the San Francisco volcanic field. They're just very young and they're very pretty. Another one, if you want to visit, I always recommend is Red Mountain. This is on the northeast side. So it's kind of, if you're going up to the Grand Canyon, you go past this. The Red Mountain is a cinder cone. It's red, obviously, based on the name, but you can see the oxidizing. But what's really cool about this, and you can see in the map there's like the whole side of it is blown out. Some sort of mass flank failure. And that's opened up the inner part of the cinder cone, and there's a trail. And it's honestly a really easy trail. There's just like one little ladder to climb is the hardest part. And you get to walk inside of a volcano. And you can walk like inside of the cinder cone and look at the walls and see all of it stuck together. And it's an amazing place to visit. And this one, again, it's older than those others, but we're still kind of on those just a couple of million years age for these, at the very, very most, for these sort of cinder cones. So this is a pretty cool one to go into. If we want to travel to some of the other ones, like I said, these are around the Mormon Mountain area too, but I've got just some other kind of places people sort of sometimes recognize. In the Springerville volcanic field, there's quite a few volcanic features here. Lots and lots of cinder cones. I think I saw somewhere there's something like 600. Is this the one? I'm double checking my notes up here. Oh, there we go. There are 501 identified vents, and a lot of those are these cinder cones. And we saw a shield volcano earlier. So this is Green's Peak, and it's just a cute little hill. It's somewhere around 760,000 years old. So this is going to be just a little bit older than a lot of the stuff we saw in the San Francisco volcanic cinder cones. Also in the Springerville area, this is Twin Knolls, and this one's kind of interesting because it's like two cinder cones that are overlapping, which is really cool, but it's not like they erupted at the same time. It's sort of a coincidence that's there. So the southern cone is the one that's younger, and the southern cone erupted about 308,000 years ago. But the northern cone that it's like all leaning up on, that erupted like 750,000 years ago. So there's like over 400,000 year difference between the two. Maybe I'm just a nerd for thinking that's pretty awesome. One of my other very favorite volcanoes in Arizona that I haven't been to yet. This is on my list that I really, really want to get out to. This is Vulcans Throne. It's in the volcanic field that's just on the northern rim of the Grand Canyon. So just like in that Arizona Strip area, there's a lot of very young volcanoes there. And this one is Vulcan's Throne. And the cool thing about it is when it erupted, you can see in this picture that the lava actually flowed down the side of the canyon, dammed the river, and created like a lake back behind it. And it was able to erode through, and the river kept going. But now there's some pretty serious rapids right through there because of it. So yeah, so cinder cones, there's a bunch of them. It's sort of the short version of that. I'm just looking at my time. I get excited and talk far too long. Sorry, y'all. Stratovolcanoes. So stratovolcanoes are sort of the thing you think about when you think volcanoes. Mount Fuji, Mount Rainier, Mount St. Helens. Those are stratovolcanoes. These are going to be made up. They're mostly layers of like ash and andesite. Because they're so thick, that lava is thicker. These tend to be pretty dangerous. This is one of the more deadly types of volcanoes. And you can see in my little animation here, it's a little bit of ash, a little bit of lava, back and forth until we make this beautiful cone. We have a few of these, but the one that everybody should know and may recognize the best is the San Francisco Peaks, or San Francisco Mountain, that sits over Flagstaff. Although this doesn't look like that nice pointy volcano that we had in the last picture, but it used to be, which is the coolest part about this. So San Francisco Mountain, it formed somewhere between like 1 to 500,000 years ago. So these are pretty young, but pretty much extinct. But it's missing the entire top. It was much taller and well over like 14,000 feet, which is just amazing. Now, why the top is gone? There's some debate. You can see I've got a picture looking at the inner basin, and it's beautiful there. That's a nice fall picture. But there is the thought that it could have maybe had a flank eruption, much like Mount St. Helens, and blew out the side because it looks very similar to that. It could have just been a landslide because these volcanoes can just be unstable sometimes. So it might have just been a landslide versus one of those big eruptions. It's not super clear. Doesn't seem, at least, to be.
I'd like to, on that picture, if you could go back to that, I want to point out to everybody watching, in that left picture, there is a triangle above the mountain. That is the old peak.
Thank you.
So that's how much is missing. It's one of my favorite diagrams.
It's a lot. And, and it looms there over the town of Flagstaff. And it's so wild to think about how much bigger it was. There's also lots of evidence for glaciers in this inner basin too. So glacial activity probably did a lot of eroding it down as well, which is wild to think about glaciers in Arizona during the last kind of ice age, during the last ice maximum, like 15,000 years ago. There were actually glaciers here in the inner basin. And there's some moraine deposits in there, and that's just the sediment deposited by those. All right, dome volcanoes. These are the ones made out of rhyolite. They're super, super thick, viscous lava. These tend to be really unstable. They sort of like form and then will blow themselves up. And of course, we're lucky enough to have a few of these. The San Francisco volcanic field has pretty much got everything. Mount Eldon, that's your other volcano that sort of looms over Flagstaff. Mount Eldon is a lovely dome volcano, and it's got these big, beautiful lobes. But we do know that it created some pretty serious pyroclastic flows. That's where you have like ash and gas that comes like blaring out of the volcano at incredibly high speeds and incredibly high temperatures. So there's really beautiful surge deposits, like over near the dog food plant. I know we went there to visit those deposits on a field trip once. So we know this had a really serious eruptive history. But it's extinct too, lucky for us. The other thing up there is Sugarloaf Dome. That is actually on the side of the San Francisco mountain. It's one of the little bumps on the side of it. This one is a dome too. There was a pumice mine. They mine out of it, but it has got some amazing pyroclastic flow deposits there too. Just to help remind us that this portion of Arizona million years ago or so would have probably been a terrible place to be. But it gets worse because we also have calderas. Now, caldera is a big volcanic hole, but we tend to think of like these caldera style eruptions or these super volcano eruptions like Crater Lake here up in Oregon or like Yellowstone. And we have some of these here in Arizona. We actually have some pretty close. I'm going to skip over how it's doing. I'm here in the valley, and I know a lot of us are pretty close. I can like look down the road and see the Superstition Mountains. These are a deposit of welded tuff or ash that was so hot that it all sort of melted together when it fell, from a series of caldera eruptions. So there's actually 3 big calderas in these Superstition Mountains. And I read somewhere there may be a couple more, but these are the 3 that seem to be the most well-known and well identified. So the oldest is the Superstition caldera at 25 million years old. The Goldfield caldera is like 15 million. And then the Tortilla caldera is less than that. And this sent ash over miles and miles and miles and miles all the way over here. So even here in the valley had a lot of this. This, even where I am now, it probably would have been horrific while these things were erupting. So we've got some pretty good ones not too far from us. There's also some really cool volcanic domes that formed in the area after the eruption. So there's some resurgent domes in the area too. Kind of Weaver's Needle. A lot of people know that. That's kind of a one of those really young rocks that was exposed thanks to some erosion in the area. And then if we head down just a little further south, one of my favorite places pretty much in the world, and especially in Arizona, are the Cholla Mountains. The national monument here, but it is well known for these beautiful hoodoos from volcanic ash. There's all sorts of balanced rocks. They're beautiful. And these are all thanks to a really big volcanic eruption. And this was caused by the Turkey Creek caldera eruption. And this was about 26.9 million years ago. So this is a lot older than the rest of them. You can see where it is. All the deposits went on for a really long time, but they're sort of pocketed there at the shore hallways that we can see now. The image on the left shows you just sort of the eruption that would have formed the caldera, and you can see these ash surge deposits coming down. And these are beautiful. It ended up depositing 120 cubic miles of ash, which is a lot. And if you want to compare it to some volcanic eruptions, you might know it was 1,000 times bigger than the 1980 Mount St. Helens eruption and like 5 to 10 size bigger of the Krakatoa eruption in 1883. So this was a powerful, mean eruption, and it's given us some of the most beautiful landscapes in the whole state, which I think is amazing. Highly recommend it. It's a national monument, and apparently it's like one of the least visited national monuments like in the country. But the Chiricahuas are sky island, so it's one of those mountain systems that are tall enough at the top of the mountains when you get to the Chiricahuas, the top of it is all like black bears and Coatamundi and pine trees and snow. It's beautiful. Highly
And
recommend
a
it.
and a lot of birds from Mexico come. That's their northern point in their range.
It is.
But
It is.
bird watchers come there from around the world just to say they saw it in the United States.
Isn't that amazing? Yeah, it's a beautiful place. It really is. And it's quiet. And if you want to do the big hike, they'll drive you up to the top of the trail, and all you got to do is hike back downhill, which is always nice. Okay, and that's is wrapping me up because I can see my time, and I know I've kind of talked right here, sort of for quite a while. But I just sort of ended back with this, so you can see those are some of the major volcanic fields. The Unkaret volcanic field, I am always so confused. I'm really did go and look and see how to pronounce this correctly. But this one is up on the northern side of the Grand Canyon. There's some really cool stuff there. Flagstaff area, that's the San Francisco volcanic field. You also have the Mormon Mountains in there. Springerville's really big. Just south of that, that's the San Carlos. So that's where Peridot Mesa is. Lots of lava flows in that area. The Sentinel volcanic field and the Arlington volcanics are there. And then mostly now in Mexico is the Pinacate volcanic field. And I know that's one that gets studied quite a bit. My background's in planetary, so I know a lot of the planetary folks go down there when they're doing some Mars analog stuff. So there's plenty of places to see some amazing, beautiful volcanoes. And since we're Arizona and it is so darn dry, they are all pretty well preserved. So you can see them in a lot of locations.
Cool, thank you. Miranda Ray has another question. Are all calderas generally very destructive, or are there some that are less destructive?
So the term caldera is an interesting one. The USGS actually kind of uses it in two ways. There's a caldera, so that's like the hole left over after like one of the caldera forming eruptions, like Yellowstone, like Crater Lake, like the calderas that I was talking about here. Those are big and they're very explosive and very dangerous. But like if you look at Kilauea, it's got a big hole on the top, and that gets referred to as the caldera. But that's mainly because when the magma chamber empties in the volcano, it sort of sinks down. It happened pretty quickly a couple of times in like 2018, but for the most part, that one is fairly gentle. So I try to be sort of careful using the caldera style eruption versus, the caldera as a big hole in a volcano kind of term. And I'm sure a volcanologist could probably clear me up a lot more than that, but I've seen the use both of those ways.
Okay, and Mike also adds that Dick Holm, volcanologist at NAU, wrote the definitive paper on debris avalanche collapse at the San Francisco Mountains.
Awesome. That's a name I ran across quite a few times. So I'm going to make a note over here to myself to go look it up.
Okay. It's in the comments, so when you...
Oh, thank you.
All right, and Steve asks, when down in the church, or no, suggests...
That's creative, Steve, but I know what you mean.
Yeah, don't miss Fort Bowie State Park.
It is pretty cool. There's not a lot there, but it's a pretty nice stop right there.
Yeah, I have not. I've only been to the Chiricahuas a couple of times, and it was all for birding. So
the animals, like the number of like mammals that they cite there is pretty amazing.
It's the only place I've seen a black bear, and I've been a lot of places there have been black bears. So
Queen Valley. Oh, awesome. Yeah, and like I said, I really skimmed the top. There are so many volcanoes I obviously did not have time to get to, but it's really amazing. And if folks would like, I can give this to Bob. I've actually created sort of a document. Bob, I stuck that in our chat box there if you would like to share it, like as a comment, maybe on the YouTube. I don't know how easy that will be for you.
I can do.
But I have a list of, if you want more information about volcanoes in Arizona, I've got a list of a whole bunch of papers and reports and field guides and websites. A lot I got from the Geologic Survey, because that's where you go. And one of the best is, if you want to see all about northern Arizona volcanoes, the Arizona Geological Survey has a story map, which is a really, really cool kind of website. And that'll walk you through a bunch of the volcanoes in northern Arizona. It's really cool.
Yes, the Arizona Geological Survey is a fountain of information on its website.
It between all the reports and all the maps and the website itself. I know I put a link just to their volcanism page is in there too. It's pretty great. It's the first place I look for stuff when I need anything Arizona.
Right. So that comment is now there.
Thank you.
With that link, you'll have to copy and paste, I think. But I'm not on YouTube, so. All right. I mean, I'm not on YouTube right now.
Right. Gotcha.
I'm all over YouTube. All right. Steve says, thank you. Great job.
No. Steve's a nice guy too.
Yes, he is. Mike says about the same. You'll see them. All right. Last chance. I've put it in a couple of times that Kelli students need to check in with I don't know what wash hands means, folks. I'm old.
I don't know.
I've only been
very hard to keep up with the kids these days.
I've only been online since 1994. That was my first website.
No, I remember like the first time I ever sent an email. I'll be honest.
I don't remember that. I remember the 3 days it took me to program the website.
Oh, wow. Yeah, back in the days of playing games on the bulletin boards, all the BBSs.
Okay, so wash hands is clapping.
Oh, okay.
Okay, great. I've never heard it before tonight. So thank you very much for educating me. All right. Any final comments, Kelli?
Y'all go visit some volcanoes. They're beautiful and snow covered coming up here in Flagstaff pretty soon. So it's a lovely thing to see those dark basalt volcanics all covered in white snow. It's pretty beautiful.
Yeah, I was kind of upset when it turned from 117 to snow. I wanted to go up in the mountains. Oh, well. All right. Got a couple of. Oh, okay.
Well, I will put a quick plug in for the Flag Mineral Foundation. The Flag Gem and Mineral Show is coming up in January. We didn't get to have it last year thanks to the Rona, but we are having it this coming year. It is January 7th, 8th, and 9th. It's the first full week in January. It is on the Mesa Community College campus, like right off the 60, where the shows are to miss. And if you enjoy volcano things, I will be setting off my sort of infamous trash can volcano and doing a little volcano spiel a few times each of those days. So come by and see my geology club's booth. We're going to be giving out rocks and minerals to kiddos and selling stuff to make our club money. And make sure you check out my volcanic eruptions.
Sounds good. Miranda Ray puts in a plug for the geology club too. So, and there's a meeting at 4 p.m. I will let you read the comments for the room.
Oh,
number.
she's reminding me. Miranda Ray is our MCC Geo Club president, and she is keeping me on track. It's an amazing thing, and it is not an easy job. So,
all right. All right. Well, I thank you very much, Kelly. I'm going to wrap it up with you still on the screen. I'm going to, let's see. Yeah, I do that and put you there and me
that's a lot
there.
of me.
And
You can,
just for
you can see my toys.
That's not what I want to do. There we are.
I got my amethyst with all my little Lego minifigs digging in.
Cool. I got jazz paintings on the wall. Okay. So there's one I did. No. There. It's one that little one there.
Nice.
Anyway, this is Devolving Facts, folks. So is our
I'm a bad
audience.
influence.
Thank you very much, everyone, for attending. We'll be back on December 15th. Please check out our website at penallgeologymuseum.org, and you'll see various things there, including our new 3D exhibits and those that are coming up. And also information about the December 15th meeting when we get there. All right. Thank you again, Kelly. And I'm going to just close us out and say good night to everyone. Good night, everyone.